let's start the chapter, or let's continue the chapter. Redox reactions. Today we are going to discuss the remaining portion, that is oxidation number, oxidation state, reducing agent and oxidizing agent, electronic concepts and half reactions. Concept means electronic concept. Electronic concept means transfer of electrons between the atoms of same molecules or different molecules. So we can define oxidation in terms of electronic concept. Oxidation means losing of electrons. Oxidation means losing of electrons. We can directly go to an example. Magnesium. Magnesium is a periodic table element which having a atomic number of 12. Okay, the valency of magnesium is 2. You all know that. So the oxidation state of magnesium is +2. That we will deal later. Oxidation state of magnesium is +2. So how magnesium will become Mg2+? By losing of electrons. How is this process happening? And we know that losing of electrons means Mg minus 2 electron is Mg2+, right? But we can't write like this because there is no method to write minus 2 electrons. There is only a method of plus sign. Addition only is possible. So how can we add? That is Mg is giving Mg2++ 2 electron. This is the way it becomes like this. So don't confuse with this thing. Okay. Now let's move to reduction. Reduction means losing, not gaining of electrons. Gaining of electrons means we can directly tell one example, that is Cl2 plus 2 electron is giving 2Cl minus. We know that chlorine atomic number is 17, valency is 1. So we can accept 1 electron. So here there are 2 chlorine atoms. So 2 chlorine atoms having 2 electrons. So they are combining to form a molecule Cl2 by accepting 2 electrons. That is the electronic concept of oxidation and reduction. Now we are dealing with oxidation number. So oxidation number means just a number of the atom or number of the element. How can we attain oxidation number? How can we write oxidation number? And there are some rules for ionic and covalent compounds. Before that, I will give a small definition about oxidation number. It means a residual charge of an atom. Wait, we can consider like this. Potassium chloride, we are taking one element. A residual charge of an atom, of a chlorine atom, when all other atoms of the compound is removed as ions. So it is the residual charge of an atom, of a chlorine atom, when all other atoms of that molecules in that compound is removed as ions, is known as oxidation number of chlorine. Okay, this is the concept of oxidation number. But if you are coming to redox reaction, there are two types of reaction, half reactions. Like oxidation and reduction are happening in a single reaction. So we are going to change the oxidation number and oxidation state here. Oxidation state. We are going to deal with oxidation state. Oxidation state means the charge of an atom in that compound. That means if you are considering potassium chloride, when we split potassium chloride will accumulate like potassium plus and Cl minus. So Cl minus, this charge is oxidation state. Okay. Now we can deal with oxidation number. Oxidation number means the oxidation state into number of atoms in that molecule. If potassium chloride only consists of one atom, so it is -1 into 1. If you are considering another example, we can look MgCl2. MgCl2, what is the oxidation state and oxidation number of chlorine in MgCl2? That is our question. Oxidation state, we can just short form as OS. Oxidation state of chlorine we already know, -1. Oxidation number of chlorine is -1 into 2 chlorine atoms is equal to -2 is the oxidation number of chlorine in magnesium chloride. Okay, this is the concept of oxidation number and oxidation state. Okay, now we are going to study the rules of oxidation number. How to attain oxidation number or how to find out oxidation number. So there are two types of compounds, ionic and covalent compounds. So first we are going to study about ionic compounds. First point of ionic compound is, in ionic compounds we are taking first point as one example. Okay, potassium chloride. Potassium chloride is a compound and this compound can be splitted as potassium plus and Cl minus. So the first rule says that the charge of the anion and cation is assigned as oxidation state of potassium and chlorine. So what is the oxidation state of K plus 1 and chlorine is -1. So the first rule is, if you are considering a compound and if we split that compounds into anions and cations, the oxidation state is the charge of the individual atom. Okay, that is the rule number 1. Next rule is, sum of the oxidation number equal to 0. That means if you want to find the oxidation state of chlorine, okay, that in potassium chloride we want to find the oxidation state of chlorine, we will find like this. We will consider as chlorine as X, and we know that potassium having oxidation state of +1. So we will write like this: X plus 1 is equal to 0 or X is equal to -1. So -1 is the oxidation state of chlorine. This is the method to find oxidation state. I will tell later, or I will discuss it later detailedly. So I just want to get an idea about the sum of the oxidation number is equal to 0. Now we can deal with the rules of covalent compounds. Covalent compounds, the firstmost rule is, any element in free state equal to 0. Example: hydrogen, nitrogen, chlorine, bromine, iodine, all are in their elemental state. So their oxidation number is equal to 0. Next point is, oxidation number of hydrogen is always +1, but in some cases, example sodium hydride, potassium hydride, calcium hydride, in these cases hydrogen oxidation number is equal to -1. Okay. Third point, oxidation number of oxygen is always -2, but in some cases H2O2 oxidation number of oxygen is -1. KO2 oxidation number of oxygen is -1/2. So these are the 3 points of oxidation number of in covalent compounds. Next one is, we discussed in ionic compounds, that is, if you are splitting a compound into its anions and cations, for example calcium chloride, if you are splitting as Ca2 plus and Cl minus, okay, or we can just take cation only, okay, Ca2 plus. So what is the oxidation state of Ca? That is +2. That is the point. That is, if you are splitting a compound into the anions, the charge of the anion or cation will be the oxidation state. Next point is, electronegative elements, fluorine, chlorine, oxidation state of -1. Okay, this is the fourth rule. And next two more rules are there. That is, group 1 element always having +1 and group 2 element always having +2. Oxidation state. Group 1 element means hydrogen, sodium, potassium, etc. Group 2 element means magnesium, calcium, etc. So these are the rules of oxidation number in covalent compounds.